What's up, guys? Welcome back to Diving Garage. We're continuing on our 350 small block Chevy build. We got a lot to do. We need to get the crank installed, check for clearance, get the pistons and rods balanced and assembled, and installed in the engine. So let's dive in. Alright, first things first, we need to get these main caps off, get them loosened up and remove them. And we want to make sure we don't get these mixed up at any point. These two, obvious, front and rear, but it's these middle ones that we want to make sure stay in the same orientation during the disassembly and then the reassembly process. So I'm just going to grab a punch and hit these with a 2, a 3, and a 4. And that one's obvious, so we don't need to worry about that one. And just so that way they never get mixed up. All right, we went ahead and marked them on the forward side of all the main caps here. So now we know which one is front and which order they go in. All right, for the hardware for the mains, we're going to be going with ARP main studs. And let me kind of lay the groundwork here. We're going to be choosing middle of the road parts, mainly from Summit. A little bit of Rock Auto in there, but we're not going to do the cheapest budget build from an eBay kit. We're not doing that. There's been so many of those videos already, and more often than not, those videos end up in failure, because there's low quality control. The parts just generally suck. They're not reliable. So we're going to be working in some budget-friendly options in the build. We'll get to that later on. But let's go ahead and go with the main studs right now. I will do a quick little unboxing of the ARP main stud kit. This part number 1345601 is for a Gen 1 small block Chevy 4-bolt main. So I open it up here. Packaging. We have some information about the hardware here, warranty information, and the real reason we spend all the money. Got your ultra torque, and then of course you have washers. This is a hex nut kit. If you can see there, this is a hex nut kit. It's not the 12 point. And then of course you got your actual hardware here. All right, so next up, we're going to be installing the bearings here, and we're going to be using a seal power kit, part number 4663M. And the point of why we're doing this is we want to get the bearings installed, main caps installed, and we want to check the bearing surface for roundness. We want to see what that size is, and we're going to go polish and measure our crank and see how those compare. We'll check to see how much oil clearance we have. So let's get it. All right, so we got all of the studs, washers, and nuts installed and greased. What we're going to do is we're going to seat all of the mains, and then we're just going to snug everything up evenly, and then we'll go in a torque sequence. And for our torque sequence, we're going to end up at 80 foot-pounds, but I think we're going to go to 60, and then 70, then 80. Well, looks like the rearmost main cap that we couldn't get wrong was on backwards. So I knew something felt funny. Let me know in the comments below if you spotted that before I did. Now we're going up to 80, final torque. All right, so I want to show you how to measure for oil clearance on your main bearing surfaces here. So what you're going to need is a bore gauge. You can find these on Amazon, eBay, what have you. And what we're going to do is we're going to put this end here inside of this, and we're going to measure to see what that dimension is, and we'll compare that to the dimension of our crank, and we'll see how much clearance we have. So these devices are pretty simple. Comes apart in a couple pieces here. So you got your dial gauge that just goes in there like so. And then you have this end. This is where you put the different size tips to measure your the bore or whatever it is you're trying to measure. So in this case, we have one of the shorter ones. I'll tell you the exact one we have in a second. And then behind that, if you can see there, we have a little spacer. So what we're going to do is we're going to put this into this here, and we're going to see what that dimension is. All right, so we're going to get our bore gauge here, set it into our surface there, and then keep an eye on the needle. What we're going to do is rotate it just slightly. We're looking for the smallest measurement. So once you found it, rotate your indicator gauge just like that and check it. So we can see it's hovering right about there. Right there. So that's our smallest measurement there. All right, we'll take it out and we'll go check that measurement. So we just took the measurement for our crank journal, and we're going to measure it and see what it is. So to take the measurement of our bore gauge, we just have this, and we know when the plunger goes to 0, we know that's our measurement, right? But that's not very helpful. We need to find a way to calculate that measurement. So what we're gonna do is get our set of micrometers out. And this set is from Summit. It's actually pretty nice. I didn't even know it came with a case. What we're gonna need here is our 2 to 3 inch micrometer. And then we are going to calibrate it and take that measurement. All right, so let's get it in the vise here. We'll calibrate this up real quick. Perfect. All right, so let's measure that reading we took from the #1 main journal. So we're gonna get our dial bore gauge, set it in here. Oh, and so we're starting from a sort of known value. These are supposed to be roughly 2.5 inches, right? So I went ahead and got this at 2.4. And what we're gonna do is take our measurement and see how far off we are. So he's gonna set it in there. I have to widen it up a little bit. Let me unlock it. I have to widen it up a little bit to get the plunger in there. And then once you get the plunger in there, it's a little bit tricky here. You need to slowly depress that plunger while monitoring your dial bore gauge to see when it gets to 0. Pretty close. All while keeping it roughly centered. Nice and easy, right? All right, so right there. Let's go ahead and lock her down. All right, so now that we got that, what the heck does that mean? Let's go ahead and go read this. All right, so we just took our micrometer off of the vise, and we're gonna go ahead and read this. So don't get too tripped up about micrometers, it's pretty straightforward. So this is a 2 to 3 micrometer, and we knew we started at the 2 inch, and we went ahead and got all the way out to 2.4. So if you can see on there, each one of these ticks here on this scale represents 25 thousandths. And as you get up to 1, then you're at 2.1. So we knew we were going to 2.5. So I got all the way up to 2.4, and we started expanding it out from there. So we got 1 tick clear, and we got the second tick clear. And look, here's the 0 mark here. Let's write it out. So this is our bearing. So we know we got 2 inches. Then we got the 4. So we got 0.4. 400 thousandths, and we know we got 25, and that one looks pretty close. So we got 2.45. There we go. So we got another one, and then so this is a little bit misaligned, if you can see, right? So then you turn up to your top section here, and all you're doing is looking to see which one matches up the closest. So if we check this out, that 3 matches up pretty dang good. Let's check the rest. Yeah, I think we're gonna go with that 3. I like that. So then we can write down 0, 0, 0, 3. So and then just add it all up. Oh, it's gonna be 5. So our bearing clearance is 2.4503. And then what we're going to do is we're going to measure the crank journal. And we're going to do the same process. We're going to take the mic, we're going to put it around the journal surface, and see what that measures out to. All right, so then take your crank, you can lay it down gently, and we're going to measure this journal surface right here. And again, we're going to get our micrometer out, and we're going to go just gently, like so, and we're going to take that measurement. And so what we're going to do here is we'll loosen up a little bit, get it kind of snug towards giving you some resistance. Don't go crazy. You'll feel the spot where the middle is. You turn it there. Once you feel like you got it, go ahead and lock it down, wiggle it off. Then we'll read this. Okay, then we just measured our crank journal surface. So now we're going to go ahead and read that mic. We'll start out again. We know we got to 2 inches, so we'll start there. All right, and then what do we got? We know we have 400,000, so let's throw that down. And we have another 25, so let's put that down. And then we have almost another 25. It looks like 21, 22. So we got 0, 2, 2, 0. And that's pretty clean, so we're going to call that right there. I'll just add this up real quick. Okay, so now we know that our bearing surface has a clearance of 2.4503, and our journal surface has a diameter of 2.4470. And so all you do is you take your bearing and you minus your journal size, and you see what the clearance is. All right, so we got our bearing width, we got our journal size, and 10. 0, 0, 0. So given those two values, we know we have an oil clearance of 3 thousandths. So that's perfect. All right, so now that we checked the clearance for this journal here, I'll go ahead and do the rest. All right, so we checked all of our oil clearances. They look great. We have about 3.5 to 4 thousandths on all of the clearances, so that's perfect. And before we move on, I just want to say, don't be afraid of this tool. And don't be afraid of this tool. I got this on Amazon, and I got this from Summit. You don't need to spend hundreds of dollars on a legit machinist tool if you're just trying to do this in your garage like I am. But you do want to make sure you have oil clearance. Otherwise, you'll have problems for the rest of your build. So next up, let's get that crank polished. All right, there are a couple different methods to polish your own crank. You can use the sandpaper method. You want to go with a least at 1,000, 2,000, a little better. And all you do for that method is you spray down the surface with WD-40. You get a cut piece of sandpaper and you can use a shoestring, but in this case, I'm going to use a piece of microfiber, a long piece that I cut. But we're not going to do that method because we just measured all of our clearances. We know that they're great, so we don't want to be too aggressive. So all we're going to do is polish up all these surfaces, get them cleaned up, a little bit of mothers. All right, so next I need to loosen up all these nuts, get the main caps off, clean everything up real good, and then before we put the crank in, we're gonna give the cylinders a quick hone. All right, so next thing before we put the crank and get that all final set is we need to give the cylinders a quick hone. So this is a hone from Rust Research, flex hone, ball hone, whatever you want to call it, bunch of different names. This is it right here. So what I would recommend is actually going to the Flex Hone website, punch in your numbers and the type of material your block is, just in case you're not doing a small block Chevy, but if you are, this is your guy right here. This is 4-inch ball hone, and what it's going to do is that it's going to deglaze the cylinder walls, and it's going to give you a nice crosshatch so that way your rings have something to bite into, and it'll make seating and braking in this engine a lot easier. So let's get to it. All right, so this process is pretty easy. First, get a clean rag, wipe out your cylinder. And then next thing's up, get some WD-40, give it a good coating. And then get your tool, also give it a good coating. And what you're going for is even strokes. Make sure you're on low speed. You're going for even strokes, down and up. Count about 5 to 10 times and make sure you're even per cylinder. That easy. And what we're going to go ahead and go do is repeat that for each of the cylinders. First, we'll go 5 times around, take a look. If it looks like it needs a bit more of a deglaze, we'll go ahead and go around 5 more times again. And in between passes, make sure you clean it up on the inside. It does make a bit of a mess. That's why we took the bearings and the crank is out right now. So we can give this a nice clean, one more clean before we start really assembling this. Just in case you're wondering, should I do this? Can I skip this? Can you skip it? Yeah, you can. I built engines before without honing them. They turned out just fine. But should you skip it? If you have the capability to do a hone, I recommend it. It really just, a hone doesn't remove a ton of material. Well, all it really does is it reshapes what's already there. So you can get this hone and you can run it for an hour and you may not even remove a thousandth, but that's not the goal. The goal is to create a new crosshatch groove for the oil to travel down, right? And like I said, break-in helps with the rings. So overall, you don't lose honing. So if you can get your hands on a hone, you're building an engine, I recommend do it. All right, so let me get you in for a closer look at this. All right, so that was 5 passes with the flex hone, and it looks like we've got a nice finish on all of these. Both sides look about the same. And again, nice even finish for our new rings to seat into. Looks great. All right, so we got the block all ready to drop the crank in. So got clean gloves on. We go ahead and place all these bearings. We're going to put in the bottom half of our rear main seal, and then we'll set the crank down. Oh, and of course, apply a nice coating of assembly grease. Don't forget that. All right, so this here is the bottom half of our two-piece rear main seal. And if you look close, there is one large lip and one small lip. The way you want to do this is you want this larger lip facing towards the front of the engine. So let's get that placed in. Also, you're going to want to offset this rear main here. So you'll see I don't have it like that to where it's even with the block. You want it to be offset like this. And you're going to add some RTV here and here. All right, so let's get some assembly lube, and then we can drop the crank in. Okay, we're going to be using some red line assembly lube. Never tried this out before, but should be just fine. So let's get all these coated and we'll grab that crank. You don't need a whole lot, just a nice good coating. There we go. All right, looks like it's found its home there. Just give it a quick rotate, see how it feels. Oh yeah. You feel the resistance of the assembly lube there. Otherwise, spins just fine. Very nice, very nice. Sweet. Whoa, looks like we spun out our rear main seal. All right, got the crank in there, spins fine. So let's get the main caps on. And don't forget to lube these up too. Assembly lube is your friend. And since we're doing this for the final time, check your marks, make sure everything's oriented correctly, because we don't want to have to come back here again. All right, this is it. Let's do our torque sequence. We'll go 60, 70, 80, and that'll be it. That should do it. Let's see if this crank spins. Should spin pretty decently easy. Yeah, there's some resistance, but it's pretty good.